All right, continuing on with our review of pre-algebra, the next thing we're going to look at is identifying which properties are used during the steps that a student took to solve this problem. So Juanita used the steps shown below to correctly solve an equation. A step is missing. Which step shows the equation that is most likely missing a step and the property that justifies the step? So let's look at what's going on here in this problem. We have negative 3 parentheses c minus 6 plus 4c equals 5 parentheses 2c plus 9. So I can see there's a missing step here from the question mark, and I can see underneath of that step, the left-hand side simplifies all the way down to c plus 18. And on the right-hand side, the steps I can see is it simplifies to be 10c plus 45. Now, I know from looking at this problem originally that if I was to try and solve this, the first thing I'm going to do is use the distributive property. So looking at these 4 choices down here, I can already cross out A and B because I know I'm going to have to distribute here and distribute here. So here are the 2 I'm going to be looking for. So what I'm going to do is just distribute myself and see which one it actually would be. So when I'm using this distributive property here, this is going to become negative 3 times c is negative 3c. Negative 3 times negative 6 is a positive 18. And then plus 4c is equal to 10c plus 45. All right? And then I can see that for the next step, we combine negative 3c plus 4c, which equals 1c right here. So I know that I'm on the right track here. So let's see which one this is. So negative 3c plus 18 plus 4c, it has to be this one right here. Because that is what I got when I distribute it. So I basically did the problem myself, but I also used test-taking strategies to cross off A and B. Since I knew it wasn't going to be the associative property, it had to be one of these because of the distributive property. All right, let's try the second one together as well. Using test-taking strategies and also just solving it ourselves to see what we get. So the next problem says one of the steps Lewis used to correctly solve an equation is shown below. We have 3 parentheses x minus 7 plus 40 equals negative 5. And I can see that Lewis used the distributive property to get 3x minus 21 plus 40 equals negative 5. So which statements describe the procedure Lewis used in the step of solving the equation and identify the property that justifies this procedure? All right, so what did Lewis do? Did he add 3 and x to eliminate the parentheses? No, he definitely didn't do that. Did he add 3 and x to eliminate the parentheses? No, he didn't add 3 to x at all. Did Lewis multiply x times 7? No, sorry, did Lewis multiply x and 7 by 3 to eliminate the parentheses? This procedure is justified by the associative property. Well, it kind of sounded good until they said justified by the associative property, because the associative property doesn't do that. It has to be D. Lewis multiplied x and 7 by 3 to eliminate the parentheses. This is justified by the distributive property. So it couldn't be A because no associative property was used. It can't be B because we didn't add anything. You don't add in the distributive property. It's not C because it says the associative property, which is not used, so it has to be D, the distributive property. All right, so the last thing we're going to do is take a look at this last page of the review of pre-algebra, and that's just some algebra vocabulary words. So variables, we already went through this. Variables are numbers used to represent, are letters used to represent numbers. We can use any letters of the alphabet. We most commonly use X, Y, we use N, A, B, and we can keep going, but variables are basically just letters of the alphabet. Constants are just plain numbers. For example, 4, negative 2, 1/3. We could keep going. Any number that's just a plain old number with no variable is a constant. Algebraic expressions are expressions that include at least one variable made up of terms. So terms are each little part of an expression. If this term was 2x, and this term was 2x, and this said minus 2x, these are all the same terms, but they're separate little terms here, showing that an algebraic expression is combined with these. All right. Terms are part of an algebraic expression that are added together or subtracted, and they can be constants, variables, and variables with coefficients. So the expression negative x plus 2x minus 8 has 3 terms in the beginning. But if I was to simplify things, they might simplify down to have less than 3 terms. So that's the next part. Before you can solve equations, you should be combining like terms, which means making it simpler. So I could take this expression here, negative x plus 2x minus 8, and combine like terms to make this 3-termed expression down to 2 terms. Negative x and 2x can be combined together because they both have the same variable. What you do is you add the coefficients, which are the numbers in front of the variables, together. Negative 1 plus 2 is 1. So negative 1x plus 2x combines down to be 1x, and then this would just end up being 1x plus 8 as our final answer. When you're combining like terms, you can only, oh sorry, that's a minus sign, I didn't realize that. This was a minus 8, so this is going to be x minus 8. I just erased it just to verify, but it's a minus 8. So when we are combining like terms, it's important to realize what is a like term and what's not. X minus 8 has to stay that way. It can't be combined anymore because these are not like terms. You can't add or subtract x with any number because we don't know what x is. So what I want you guys to do now is try these 6 problems below. So we have a bunch of different combining like terms problems. Some of them you have to use the distributive property and then combine. Some of them you just can start combining. I suggest that when you have like terms that you are combining, circle them a certain way or underline them so you can see what you are combining together. I'll give you guys a few minutes and then we're going to go over the answers before the end of class.